Hello, I'm going to be talking about volume rendering. It's a very important and very new field that's coming into rendering these days. The problem with traditional renders is they render everything hollow, and while initially you might disagree with that fact, it's actually quite a big problem now that we're dealing with more sophisticated rendering techniques. You've noticed that in some games you can, once you put your character's head out a wall, or the camera that represents the character's eyes, you can see through the entire world sometimes in some games. And this is a very big problem. Volume rendering is taking the normal approach, but steering away from the normal approach, I guess, in some ways. And instead of drawing an outline of everything, which is the outside casing, it instead draws everything. It draws the entire outside, the inside, it draws everything from every angle. It's amazing. And the reason why this field even developed in the first place was for two main reasons. The first one was for medical reasons. For example, CT scans of the head and body. They used to be represented in two-dimensional slices, but now we can take those two-dimensional slices and build a 3D representational model and fly through the brain, so to speak, or through the body, to locate areas of interest or to filter out the noise of areas of not very interesting things. The second reason why volume rendering was created was a more efficient approach to doing more realistic surfaces such as fur. Now, fur is a very broad and general term describing many different things, all the way from fur as in actual hair or fur on the body, well, hopefully not on your body, maybe on a dog or a cat or a tiger, fur on a rug, or even complex things such as grass and leaves on a tree, believe it or not. Well, it hasn't been yet used for leaves on a tree, but there's no reason to say that it can't be used as leaves on a tree. Just no one has put in the effort. The problem is, I searched volume rendering on the internet, on Google, and I came across the volume rendering and how it's used, but I didn't actually come across any way of actually implementing my own volume rendering in my applications. And while industries such as the Valve Corporation, Steam, and they made Half-Life, I don't know of many fur texturing examples from that. But more and more complex games are starting to use these more and more complex things. But the problem is there aren't any resources out there because it's such a new and unexplored field. It's just hard to really get a grip and start at the beginning for something like this. That's why I'm creating this kind of video tutorial to do a step-by-step instruction on just how to do volume rendering. And I'll be talking and I'll be drawing on this whiteboard, which I'm actually lacking a mouse at the moment, so I'm going to pause. Okay, I've got a mouse again. It's good. I like having a mouse. It makes drawing a lot easier. Now, fur can be used on pretty much anything that's procedurally generated. Procedurally generated is a big term to swallow. But by procedural, I mean that each object isn't tailored to the scene, rather given several constraints, such as area, minimum, maximum sizes, gravity, wind force, direction, thickness, coloring, and density. The fur can be generated either the same or different each time, but it's always generated with the given constraints. It's never generated using textures, never generated using physical constraints such as models and polygons. It's always using those very small constraints. Now, this constraint-based procedural generating has several implications, some good, some not so good. The first is basically no hard drive footprint. I mean, you can obviously see that storing 10 or 20 floats or integers or doubles, however you want to implement it, is very small on the scale of being able to draw huge fields of grass or lovely flowing hair. It's very small, and we'll see that later on. The second implication is that you get the density independent operations happening. Density independent operations is also another complicated concept, But it basically means if you're going to draw one blade of grass, you might as well draw 4,000 blades of grass because it's going to be practically the same, computationally speaking. In memory, it will be the same as well. This is obviously a crazy concept to think of one blade of grass being practically equal to 4,000 blades of grass, and you're wondering how can the engine possibly do both at about the same rate. That's why this system is so lovely. Effective utilization of these implications is something that needs further discussing later. But the last implication worth mentioning is the principal drawback of volume rendering, which is often the drawback with any rendering technique. That is mainly rasterization and ray tracing, which are the current two competing techniques. Ray tracing is starting to gain a bit of ground now. Volume rendering cannot be used to create shadows. Shadows simply don't work. You can draw shadows over the top of generated surfaces, but you can't have the fur itself do a shadow. Usually this isn't a problem because it's so densely packed that shadows kind of don't really matter anyway. But it can be a serious drawback, and it can be a reason to not use volume rendering under certain situations, or to switch between it. To do most of, say, your grass and your plains as volume rendering, but the immediate area around the character you might want to do with actual models that can cast shadows using rasterization and ray tracing techniques. That's the only thing to really keep in mind about that. I'm going to be going over a basic set of instructions, like a how-to guide to volume rendering. Hopefully you can follow along at a reasonable pace. It's a complicated, complex concept, so don't feel bad if you can't follow along, because I'll be going 10 miles an hour just to fit this into a nice short video. I will be explaining everything in a lot greater detail after I finish going through the basic steps, just to give an understanding of what you're doing, where you're going, and how you're going to do it. So, first, we usually have a scene in our that we want to render, and this scene is generally made up of primitives. Now, a primitive is any such shape like a triangle or a quadrilateral. Now, I'm going to draw this scene out of quadrilateral primitives. And the first step is to actually choose one of these primitives that we're going to volume render. Alright, so we'll choose this one. This one right here. Oh, this mouse is shocking. Can't draw anything. I need a pen mouse. Once we have that, we can take that over here, this quadrilateral, or triangle. I'll go into a bit more detail later why we only want to deal with quadrilaterals or triangles. Typically, you'll only ever deal with triangles. You won't even deal with quadrilaterals. And if you don't know why, then I will explain a bit of it later, but you really should be doing further research to find out why you only want to deal with triangles. But usually you do only deal with triangles and quadrilaterals anyway, so it's not really a big deal. And right after getting your polygon, this primitive, you're going to pass it to a volume rendering system, which you're going to create. So you get this polygon from the scene, and you pass it to your rendering system. And what your rendering system will do is, on top of this quadrilateral here, it's going to create another quadrilateral. This is shocking. It's going to create another quadrilateral on top of it, and it's going to do it again. And I'm going to give this a term called pancaking. Now, unfortunately, I have to create all the new terms for volume rendering concepts because these things simply don't exist on the internet. So little is out there about volume rendering, how to do it, how to implement it. It's like it's a closely guarded trade secret for companies that they want to keep to themselves and go, well, we can do this and you can't, and we're going to make loads of money off you. Kind of attitude that companies usually have these days. So you create a pancake stack of primitives, and this goes up for however high your fur will be. And the more sheets you have in between them, the more realistic your fur is going to look, and the higher obviously it can be. Keep in mind that these pancakes are squished together so tightly they're barely, oh well, that shouldn't be distinguishable. So that's the first layer, that's the second layer, and so on and so forth. And these pancakes are built on top of each other on this quadrilateral over here. And we'll see more about that later. After we create a stack of these, we pass all of these on and we attach a shader to each and every one of them. So we go ahead and we attach a shader, and our shader is going to be a procedural generator of our fur. It is going to take various constraints mentioned previously, size, maximum size, minimum size, density, those type of things. And it's going to create, for each of these layers, it's going to create kind of like some dots all over the place for each layer. And what happens is, although this doesn't look like anything at each layer, when you stack these on top of each other, they turn into something miraculous. They stack together and they actually form fur based on the constraints.